I'm gonna apologize because maybe I'm gonna need my notes to be more fluent with my English because I didn't study so much. But okay, to start, it's important to say that water is present in every stage of oil field life, from exploration through development, and this is one of the reasons why the use of water is a very common technique to extract oil from the subsurface and in a more efficient way, okay? But this resource can be a problem when its production is not well controlled. According to Bailey and others, which are researchers from Schlumberger, as oil is produced from a reservoir, water from an underlying aquifer or from injectors' wells eventually will be mixed and produced along with the oil. As a result, water flows along with the oil from the reservoir to the surface facilities, and at the surface facilities, water is extracted for disposal or to be injected on wells that are under secondary recovery treatment as like water flooding, okay? Globally, with every barrel of oil, 3 barrels of water are produced, are minimum, and this as minimum. And this proportion can be higher in the majority of mature fields. Sooner or later, the water production can get to the point of representing more than 90% of the volume of liquids that are taken to the surface. Consequently, the surface facilities get overloaded, and the profitability of the field can be break or threatened by this. So I'm gonna name like the most common problems that are faced for the oil industry. These problems are relatively similar, but they have differences between the water is connected with the oil, okay? And the first problem is the casing, tubing, or pack leaks. Leaks are kind of fractures or faults, and these leaks through casing, tubing, or packers allow water from non-oil productive zones to enter to production stream. Okay, even if the well is going through different productive zones, with the completion of the well, they make kind of small holes where the oil going through the tubing and go upstairs to be extracted and processed. But if it exists any leak between the casing and the formation or reservoir, it can be, the density of the water allow that the water can rapidly break into the oil, so it can be mixed. Another problem is fractures between injector and producer. This is in fields where the system is the secondary recovery treatment is water injection. Okay, it's used to maintain the pressure in the reservoir that permits the oil goes upstairs. And so in naturally fractured formations on the water flood, injection water can rapidly break through into producing wells. I found this kind of a screen of a simulating program which is used to control the water production in fields. So here is you can see the injector well, and here's the production well. So there are different locations, but underground, these lines represent the fractures or the ways through the water, the ways where the water can go through. So especially finally, in this kind of treatment, this kind of fields, the water production should be really monitored or controlled, because besides the water injection that you are using to produce oil, a higher percentage of oil, there exist fractures in the reservoir, so they can communicate easily the oil and the water. And the other problem is fractures from a water layer, and a layer is like is an aquifer, and it's kind of a big rock with a high permeability, and it contains water inside. So if this zone it contains natural fractures, the water can easily go through upstairs and mix with the oil. So water can be produced from fractures that intersect a deeper water zone. I don't know what happened, but in these cases, the water production should be monitored, should be more controlled than in reservoirs without an extra source of water. These are the reasons why oil producers are always looking for economic ways to improve the production of the oil, because all of these operational expenses, such as pumping, lifting, treatment of the water, among others, are added to the overall cost. So, water control services have proved to be one of the fastest and least costly routes to reduce operating costs and improve hydrocarbon production simultaneously. So according to, okay, I don't know what is happening, but yeah, I don't know. But the first step in water management is the evaluation and diagnosis of the water system. The process usually begins with the compilation of information of the reservoir's information, history of production, and the surface facility system. And with all this information, engineers can identify economic obstacles and acquire knowledge of the water flow mechanisms in the reservoirs, the wells, and the surface system. And finally, they can implement a management program of the total water. Okay, well, I forgot to say, sorry, that, well, okay, there exist technical tools that engineers and oil producers can use to improve the management of the water, okay? But also, it is important to say that, I'm finishing, that it is important to study the reservoir, the complete reservoir, and the movement of the fluids underground after planning new locations of wells, because the location of the wells, that is important key to avoid these kind of problems. And to conclude, the produced water keeps being a necessary subproduct, although tedious, of the oil and gas production. It is necessary because, well, almost all reservoirs have water, and also the water treatment, the water injection is less expensive than other methods of recovery of oil. So that's why it's the first option for producers to use water for impulse the oil upstairs. The efficacy of a mature field system is often related to the managed capacity of the produced water. As I said before, the water and production oil are inversely proportional. I mean, if oil producers produce more water, they're going to produce more water than oil. So the important thing is produce more oil than water, because you can dispose of the water again on the ocean if you use of the ocean, but that means cost. I mean, you don't just take the water and put into the ocean. You need to transport the water, and you need to use, if it's in land, big trucks for that, and everything is money. So the idea is to avoid the excess of water. And according to Burnett, who is another researcher, the key to water control is diagnostics. This includes to identify clearly the problem on time and keep a good surveillance of the fluid's movements into the reservoirs, as I said before. So, thank you. If I have any questions.